voltage, current, and time period required for you to charge the initially used batteries, and application of electrical engineering principles to analyze your charging and battery condition. And also, we learn the testing operations of the light bulb engineering. I hope upon viewing this video, you subscribe, like it. Thank you very much. Enjoy watching. Guys, now I'm preparing for your material on how the charger to be connected on the batteries. For here, I have the power socket, I have the charger, I have the fuse, I have a negative terminal here, and then I have this wire going to the selector switch position number 1 and this selector switch position number 2. So, by putting this selector switch on this position, you can charge the battery at the same rate. Take note that this connection is not good because never connect your batteries in series to your charger, because if you do that, you may get higher ampere current flow that will broke your battery or your charger. Okay guys, now you know what is the proper and correct way of connecting the charger into a battery. Now I am going to show you how I fix the problem with my light bulb and rescue bolt batteries. First, I separate the two batteries. I connect the two batteries with 82 ampere hour rate in parallel connected to the charger, and I put additional switches. Also, I connect the two batteries in parallel having 150 ampere hour rate with 12 volts connected in a charger with separate switch. What I'm going to do there is, if I like to charge the battery having 82 ampere hour connected together to the charger, I'm going to switch up the switch going to the 150 ampere hour rate 12 volts battery. And if I like to charge 12 volts battery with 150 ampere hour rate, I'm going to first switch off the switch going to the 82 ampere hour rate, and I'm going to adjust the current by 15 amperes. I will show you how. Guys, this I'm preparing for you to explain what I did in battery to charge it. First, this I put one battery here, I put one battery number 1, I put battery number 2, and I have a charger. This charger have a negative terminal and positive terminal, and also this negative terminal I connect on the negative terminal of battery number 1. And I make also negative terminal of the battery number 2 connected together with battery number 1. Then need to charge the battery 1 or battery 2. So in this situation, I put toggle switch here. There is a toggle switch. I connect the wire here. I put 20 ampere fuse. In this toggle switch is moving. If you want to charge the battery number 1, you can position this switch on this position and you may get to charge the battery 1. And if you want to charge the battery 2, you can switch this switch on this position and you may charge this battery number 2. Now you are able to know how to make connection if you want to charge your battery individual, battery 1 or charge the battery 2. But now I make a modification of my wiring diagram. What I'm going to do, we are going to charge the battery at the same time with the same charging current value. Charge the battery at the same time at the same charging rate. First, I have a charger here. I have positive and negative. This I have here battery 1, I have here battery 2, I put here toggle switch, I put here the selector switch. By positioning the selector switch in both, in this selector switch either 1 or 2, you can charge the battery at the same time. This is a triangle mechanism inside of a switch contact and need to exercise it. We need to check if these switch contact are able to engage both battery in parallel. In order for you to check, we need to locate it in both and measure the voltage on individual battery. If the voltage on individual battery have same voltage, example this is 11.9 and this is 11.9, it means to say this triangle mechanism contact point are able to connect the battery in parallel. Okay guys, now you know how to make and how to charge a battery at the same time. Now I'm going to remove this charger as part of maintenance. Since I found this charger is very dirty, I'm going to bring it in the workshop. I will clean, I will put 2 switches, and I will put also terminal lugs. We will remove the cover and we will see what's inside this battery charger. From here you can see there is a lot of dust. Here, negative or positive, small pen, and wizard. Okay guys, now I'm cleaning this charger by air. Now I just completed the electrical wiring configuration for my battery charger and to the battery. What individual switches for battery number 1 and for battery number 2. Now we are going to test this wiring. This circuit breaker is off. The start is into 0 position. As you can see here, I have to put the negative terminal here going to this negative terminal. In this positive terminal for battery 2, in this positive terminal for battery 1, I put it in common with positive terminal of the charger. Things work. First, make sure that this battery switch number 1 for live boot number 1 and this battery switch number 2 for live boot number 2 are in off position. So for these wires and these wires and these wires are going to the switch. So these wires and these wires are not getting contact to each other. For this scenario, you cannot charge, you can, unless you switch on this switch. Same things also here in battery number 2. I have one wire from the charger going to the switch. When this switch is off, you are no longer able to charge the battery set number 2 on a lifeboat number 2. My rheostat in 0 position. I switch on the breaker. I have here positive terminal going to the switch of my battery set number 1 for lifeboat number 1, and also I have here negative terminal going to the negative terminal of the charger. From here, initially I have 1.6 volts at 0 ampere. Switch on this, you will see the voltage from the battery. I have 12.0. I make again 10 amperes. If I generate 10 amperes, I have here equivalent voltage. By having 10 amperes, I need to increase this rheostat gradually. Having 5 amperes and having 10 amperes. As you can see here, while increasing the voltage, you may also increase the current that you are going to impress or apply on the battery. So guys, I have here the 10 ampere value. This 10 ampere value have equivalent voltage of 20.5. Having this, you can charge the battery set number 1 for lifeboat number 1. After what you need to do, you have to reduce this from 20 volts to 0. This must be switched off, and then you are going to switch off the switch. You see, after a minute I'm charging the 12 volts, I make it 13.7. This is how fast a battery can charge using this system. The charging condition of your batteries, even without going outside, you can see here it's dropping. So I'm going to show you also if I'm going to switch off this switch. You can see here the battery now is not giving energy or voltage because I switched off this switch. Make a battery full charge. Now my lifeboat number 1 have 13.7 volts. Before, the 12 volts become 13.7 volts, 13.2 volts, and we will see if this voltage will able to start the lifeboat battery. Here in the lifeboat number 1, we are going to test now if this fully charged battery will be able to start the lifeboat engine. Connected, both of them is having 82 ampere hours. After 2 hours and 5 minutes charging, we can have is able to charge by 13.7 and another one is 13.0. Now we are going to test if these two batteries are able to charge. First, I'm going to put this in battery number 2. A battery number, I need to make this glow. It will be light up and the voltage is dropping. It's finished from illuminating. We can measure the voltage from 13.9 become 13.6. So having voltage of 13.7, okay, start. See that the light is strong. We have battery. Now by 13.7, we are able to start the engine. Okay, we are going to stop the motor. We are going to test the battery number 1. This is battery number 1. We are going to measure how much voltage is. Battery 1 are now having 13.4. Making again the glow test. This 13.4 will drop by 12.7, 12.8, 12.6. We will wait until this glow off. By glowing off. Now from 12.6, we are going to test the batteries. Okay, now we are able to test and start the light bulb. 2 hours and 18 minutes charging. We are able to make this number 2 of the light bulb number 2 from 11.9. We are able to charge it by 13.9 volts. Take note, from 2 hours and 18 minutes before, the voltage from the charger in parallel with the batteries, I have 20.6. Now the voltage is increasing by 21.7. From 20.6 increased by 21.7. And also the current here, before 15 amperes, the current is dropping by 13 amperes, 12.5. So after 2.5 hours to test the light bulb, if in 18 minutes, this battery number 1 from 11.9, we are able to charge it by 13.2 volts. Now we are trying, we'll be able to start the light bulb engine. By same procedure, I make a glow test. From 13.2, it drops by 11.0 volts. From this 11.0 volts, after a glow disappeared, we will try to start the engine. From 11.7, it will rise again by 12.6. So start the engine. Yes, we make it by charging the battery from 11.9 to 12.7 volts within 2 hours and 18 minutes. The battery number 1 will able to start the engine. Okay, now we are going to test the battery number 2. By putting this in position 2, we are able to start 10.7. By making this glow test, it will drop from 13.7 to 12.6, 12.5. We will wait this glow until disappear. You see, 20 seconds. this battery from 13.7 become 12.9. Okay, we start again the lifeboat engine using battery number 2. Okay, we are able to start the lifeboat engine using the battery number 2 individually. We made a simulation test. We found out the charging time requirement for these two batteries in parallel connected, having 150 an hour rate from 1 hour and 45 minutes. It becomes 2 hours and 18 minutes. Remember, this battery, before this battery,